Okay, excuse me. We want to calculate the limit here. So the way we do this is to note that if I have 1 over n squared plus 1 plus 1 over n squared plus 2 plus 1 over etc., 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 1 over n squared plus n, that this number here in the denominator, this is the largest denominator, which makes this guy here the smallest value. And then logically, then this one here is the maximum. So the sum of n numbers will be less than or equal to n times the biggest single number in that sum. And that sum will also be more than or equal to n times the smallest number in that sum, 1 over n squared plus n. So that means then here I'll just divide everybody by n. And here, I think I'll do the same thing really. Oh, sorry, I wrote plus 1. Yeah, no, that's right. It's n times the biggest one, which is that, yeah. Will I divide it all by n? Yeah, I could. That's 1 over n divided by n is 1. N squared divided by n is n plus 1 over n. Now, if I make the denominator smaller, I make the overall fraction bigger. So, yeah, that is 1 over n there. Yeah. Yeah. I make the denominator here become this by dividing everybody by n. But this denominator here, if I knock off the 1 over n to just leave n, I've made it smaller because n is positive, and so I've made the whole fraction bigger. Is there a possibility for equals here? Is there a value? I don't think so. Guess as n's going to infinity, but it wouldn't be at infinity. So yeah, I'm right in not having the equals here. And I'm going to leave it like that. So now if I take the limit as n goes to infinity, what I'd end up having here, 1 over infinity, so that'll be 0. And that's our question. And that's 0. So by the squeeze theorem, what we've done is we've squeezed this series in between two limits of 0. So we end up saying that the limit here has to be 0 by squeeze theorem. We have the limit as n goes to infinity of 1 over n squared plus 1 plus 1 over n squared plus 2, etc., etc., all the way 1 over n squared plus n. That will equal 0. Not a particularly surprising result, to be honest. Yeah, it's not really a surprising result, is it?